What's up guys, and welcome back to another video. I know it's been a long time. I haven't been here. Khalil has been doing all the heavy lifting. He's making a video as we speak right now. But for now, let's focus on the topic of today's video. Inverse functions, inverse operations, something you use all the time, even when you're not noticing. Inverse operations are the most useful when you're solving for an x, solving for something. And today I'm going to be doing a review over all the inverse operations, or at least most of them. And this is going to be a part of a new series we're making. I have no idea what it's called. Most likely Algebra Oversimplified. And this is going to be a series about a rundown over all concepts related to either algebra, calculus, geometry, trigonometry, and we're just making them simpler for someone to understand them as either a review for a math exam or just if you don't understand the lesson your teacher gave you. So let's start with the video. Starting off with addition and subtraction. This is the simplest one we have here, and basically here we have x plus 14 equals 27. We need to isolate x. How do we do that? We do it by minusing 14 on both sides. When we minus 14, we're basically doing 14 minus 14, which is 0. So these cancel out, and you get left with 27 minus 14. 27 minus 14 is 13. So we have x equals 13. And it's that simple. Let's go on to the next one. Negative 5 plus x equals 15. And here, again, it's simple. We take the opposite of negative 5, which is positive 5. When we add positive 5 on both sides, negative 5 plus 5 is 0. So these cancel out, and we get 15 plus 5, which is x equals 20. And it's that simple. If you want to make sure that you got it correct, you can just plug in the x back into itself, and you get, just do the operation. 13 plus 14 is 27, so it's correct. And 20, if you plug in 20 here, negative 5 plus 20 is the same as 20 minus 5, which is indeed 15. So they're both correct. Now let's move on to the other thing. Okay, now we move on into multiplication and division. For multiplication, let's take 3x equals 15 as an example. And obviously this is again very simple. We just divide 3 on both sides to isolate x. And this works because the 3's are going to cancel out. It's the same as doing 3 divided by 3, and that gives us 1. So that's going to leave you with x equals 15 over 3. 15 divided by 3 is just 5. So x is going to equal 5. And that's for the first one. For the second one, let's say we have x over 9 equals 4. Here, what we can do is multiply 9 on both sides. And the 9's here are going to cancel out. Now, why does this work? Why do the 9's cancel out? It's because it's the same as doing 9 times 1 over 9. 9 times 1 over 9 is the same as 9 over 9, which is the same as, obviously these cancel out and you get 1. The same as the top. So when these cancel out, you get left with x equals 4 times 9. 4 times 9 is just 36. So x equals 36. And that's it for multiplication and division. It's that simple. Now let's move on to the other part. Now we have exponents and roots. This one is the most confusing because you have something called the principal root, which usually when you take the root of something, of a number, you get only the positive part of it, not the negative. And this is slightly confusing, so we're gonna make a short about it. So stay tuned for that. For now, I'm just gonna solve these. Here you have x cubed or x squared equals 4. What we can do is simply we can just square both sides, and the square and the square root and the square are gonna cancel out. So we're gonna get x equals square root of 4, which gives us, or positive negative the square root of 4, which gives us x equals positive negative 2. Easy. Now for the next one. Here, the square root of x equals 2. We can just square both sides. And again, the squares cancel out, the square and the square root. And here, we're gonna get x equals 2 to the power of 2, which is 4. So x is gonna equal 4. And it's that simple. Now, why does this work? Why does like raising the square to the power of 2 cancel it out? And it's because when you have the square root of x, it's the same as x to the power of 1 over 2. And if you take this 1 over 2 to the power of 2, using the exponent rules, we can multiply this to this. So we're gonna get x to the power of 2 over 2. And as we know, 2 over 2 is just 1, so we get x. And that's how it works for both this and this part. Hope that was understandable. Let's move on to the next part. We go back to the same idea because I forgot to mention something. The thing I just talked about, if you have like the square root of x and we raise it to the power of 2, and let's say we raise this to the power of 2, gives us x to the power x equals 4. And this doesn't just only work for the square root or to the power of 2. We can also use, to generalize it, we can do the nth root. So this could be the cube root, the fourth root, whatever. The nth root of x equals, let's say any number, any constant. If we raise that to the n, okay, this and this cancel out. So if we have the cube root of x and we raise the cube root, how do we cancel the cube root? We just raise it to the power of 3. And the same thing happens for the fourth root. We raise it to the power of 4 and those cancel out. And that's basically it. Now on to the logs, natural logs, and e. Those are the ones you try to avoid as much as you can because they're the most annoying. And well, rightfully so, because they are annoying and you should try to avoid them if you can. But for now, if you can't avoid them and you're stuck with them, you can just, well, I'll go through them for you. For the first one, log base 2 of x equals 3. What do? You can just raise both sides, or like put the base of both sides to 2. So basically it would be 2 to the power of log base 2 of x equals 2 to the power of 3. And this and this cancel out, and you're left with x equals 2 to the 3, which is x equals 8. Now on to the next one, this. For this, you just, again, you can just raise raise x to the power of log base x times 16 equals, and this, you do the same thing here. And obviously this and this cancel out, and you're gonna get 16 equals x to the power of 2. And obviously we already know how to solve this from the last time. You can just square both sides and you're gonna get x equals the square root of 16 is just 4. And yeah, that's how you solve this one. For these are much easier, luckily, because we have natural log and the e. For this, ln of x equals 5, we can just raise both put the base of both sides as e, and e to the ln x cancels out, and e to the 5, well, it's just e to the power of 5. So you're gonna get x equals e to the power of 5. And that's it for this one. Here, we can do the opposite operation, or the inverse one, and we can just do ln on both sides, and we're gonna get the e and the ln cancel out, and you're gonna get x equals ln 1. Ln 1 is 0, so you're gonna get x equals 0. And well, that's actually not all of the different ways you can solve this. Obviously you have the natural log rules, but I'm not gonna go into these. This is a quick revision. You should go check your rules on the textbook. Let's move on to the next part. Now we move on to the trigonometric functions. Those are fun, they're simple, and they can be very annoying at times, but they're not in here. Okay, we have sine of x, tan of x, and secant of x. And honestly, these are very simple because you have the arc sine and the inverse functions. And obviously, if you want to isolate x in each one of them, we take the inverse. So for the first one, sine of x, we can just take sine inverse of sine of x, and the signs would cancel out. And you'd get sine inverse of 0, which is just x equals 0. Now on to tan of x equals 0. And again, we just take tan inverse of tan of x. This and this cancel out, and you'd get here tan inverse of 0, which equals, or which gives you x equals 0, because tan inverse of 0 is just 0. And here we have secant of x equals -1. We can again take the inverse secant of x. This and this cancel out, and we're gonna get here inverse secant of -1, which is pi. Inverse secant of -1 is pi. So we're gonna get x equals pi. And it's that simple. And that's it for the trigonometric functions. So, hope you enjoyed the video. I was gonna mention the W-Lambert function, but I've realized it's much better fit for another video since it's very long and it needs a lot of stuff. So you guys are gonna see a continuation to this inverses video. So enjoy this. I hope you enjoyed this video. I hope you learned something, and I'll see you in the next time, probably in 5 years. Goodbye.